Hello, my dear students. I welcome you all once again to our online lecture series. In this video, I will be talking about the isoquants and marginal rate of technical substitution, MRTS. All right, let's delve deeper into the video.
Hello and welcome to this video on isoquants, MRTS, and optimal input combinations, presented by Dr. Chingshubham Manimohan Singh. We begin by examining the transition from the short run to the long run. Strategic implications include shifting to entire production process efficiency and exploring optimal resource allocation with variable inputs like labor and capital. Understanding these timeframes is crucial for long-term cost minimization and strategic business planning. Isoquants map a firm's production possibilities. An isoquant is a curve showing all input combinations that produce a specific output level. They are downward sloping and convex to the origin, reflecting diminishing marginal returns. Different isoquants cannot intersect. An isoquant map is a collection of multiple isoquants, each representing a different output level. Higher isoquants, further from the origin, denote greater output. This framework helps visualize production possibilities and identify efficient strategies across different scales. The marginal rate of technical substitution, or MRTS, measures the rate at which a firm can substitute one input for another while maintaining constant output. Mathematically, MRTS equals the ratio of marginal products. The diminishing MRTS reflects the changing productivity as relative input quantities shift. The MRTS formula is derived by setting the total differential of output, delta Q, to 0, as output is constant along an isoquant. This results in MRTS equals MPL/MPK, showing the rate of substitution depends on the marginal products of labor and capital. An isocost line shows all input combinations a firm can purchase for a given total cost. The equation is TC equals WL plus RK, and its slope, with R, represents the relative prices of labor and capital. Changes in total costs shift the line, while price changes rotate it. The least cost input combination occurs where an isoquant is tangent to an isocost line. At this point, the MRTS equals the ratio of input prices with R. This ensures the last dollar spent on each input generates equal marginal product, providing the most cost-efficient solution. Returns to scale measure how output responds when all inputs increase proportionately. Returns can be increasing, decreasing, or constant. This differs from diminishing marginal returns as it involves changing all inputs, not just one, to scale production. The expansion path traces the least cost input combinations for every output level as the firm grows. It connects all tangency points between isoquants and isocost lines. This path reveals input preferences and guides strategic decisions for long-run growth and cost efficiency. In summary, isoquants and isocost lines determine long-run optimal production. Cost minimization requires MRTS to equal the input-price ratio. Returns to scale analysis and the expansion path provide a roadmap for maintaining cost efficiency across different scales of production. Mastering the balance of labor and capital drives long-term competitive advantage. Technological shifts redefine the efficiency frontier, and scalability depends on understanding returns to scale. Thank you for viewing this video.